Now we introduce a technique for computing the answer to a linear system that works only if the linear system has a very special form. It's called a triangular system. Here's an example. To solve this, let's rewrite x as the vector of x1, x2, x3, and x4. Then the system looks like this. How would we solve this system? Well, look at the last fourth equation. From this, we can immediately derive the value of x4. Having derived the value of x4, we can plug it in to the third equation and solve for x3. Now we've got x3 and x4. We can plug those in to the second equation and solve for x2. And finally, plug x2 and x3 and x4 into the first equation and solve for x1. So here's how that works. We solve this fourth equation to get, the fourth equation states that 2x4 equals 6. We can solve that to get x4. We plug that in to the third equation, and we find out that 1x3 equals minus 19, so x3 is minus 19. We plug x3 and x4 into the second equation. We find out that 3x2 equals 54, so x2 equals 54 over 3, which is 18. And finally, we plug x2, x3, and x4 into the first equation. We find out that 1x1 equals minus 67. So we've solved for all the variables. Now, how would we implement this in Python? Well, I'm going to suggest a hack. You initialize vector x to the 0 vector. And now the procedure will populate the vector x entry by entry. At the point where you have to solve for some entry xi, the subsequent entries in the vector will have already been populated. So we can use the dot product to help simplify the calculation for that entry. So, for example, suppose we're solving for x2 using this equation. Well, at that point, we already know x3 and x4, and the vector has those entries populated. So that we can take the dot product and compute x2 in this way. So here's the code in Python. Given a list of vectors, and given a list of the right-hand sides, this calculates the values of the vector x. A couple things to note. If the number we divide by is 0, there'll be an error. So we have to make sure that these numbers are non-zero. But if they're non-zero, there's only one solution, and this procedure will find it. Now, our code so far only works if the vectors in row list have the domains 0 through n minus 1. So we can rewrite this to be a bit more general. But if we do so, we have to specify in what sense this linear system is triangular. And that requires specifying an order on the domain of the vectors. So here's the code for that.